Okay, students, today we're going to talk about parabolas. You've done this in Algebra 2 earlier, but now we're going to talk about different pieces of the parabola. And if you're given different information about it, how you can come up with the equation of a parabola. Okay, talk about Algebra 1, dealt with a little bit in geometry. You've done it earlier in Algebra 2 here, and now we're doing adding on to the parabola itself. Okay, so we see where it says standard form of an equation. This is actually called vertex form. Okay. This vertex form is of a parabola that opens up or down. When it's solved for y equals a times quantity x minus h squared plus k, that opens up or down. If a is positive, it opens up. If a is negative, it opens down. Okay. The reason it's called vertex form is h comma k is the vertex. I can get the vertex right out of there. Okay. Notice we also have an x equals a times the quantity y minus k quantity squared plus h. That is in vertex form also, but those parabolas open left or right. To the right if a is positive, to the left if a is negative. And that vertex would be h comma k also, because h is connected to the x and the k is connected to the y. Okay, so we haven't dealt with parabolas yet that open left and right. We've only dealt with this form opening up or down. Okay, so now we add in that form as well. Axis of symmetry, remember that means where it reflects directly back onto itself. So if I have a parabola that opens up or down, that axis of symmetry goes right to the vertex, and it's just a vertical line. It's x equal, and it's just the x coordinate of the vertex. Okay, x coordinate, which then in this case the x coordinate is h. Okay, that's why you see x equal and h right there. So standard form of a quadratic is ax squared plus bx plus c. Okay, that's standard form. This is vertex form, both of these. Okay, the vertex, h comma k, we've already dealt with that before. Okay, in both of those. The h is always connected with the x coordinate, and the k is always connected with the y coordinate. The focus. Okay, so what a focus is, there's a point inside of here. It's called the focus. That is equidistant. There's the vertex. Equidistant on the other side is called the directrix. Okay, any point on this focus is if I pick from here to, let me change the color here. From here to say this point right here, that would be equidistant from that point to the directrix. It may not look like it because I don't have it drawn correctly. Okay, so if it was really that long, then this directrix, this focus would be way down here, more closer to the vertex. And so then when you get out there, that distance ends up being the same. Okay, so any point on the parabola is equidistant from the to the directrix and the focus. Okay, just you know, so the focus is always inside the parabola. The directrix is always outside the parabola. Another difference, the focus is a point and the directrix is a line. It's dashed or dotted because it's not part of the parabola itself. Okay, the direction of the opening, I already told you, if a is greater than 0, opens up, less than 0 opens down, a is greater than 0, it's to the right in this form, and negative to the left. Okay. The length of the lattice rectum is the absolute value of 1 over A. Okay. So the focus, we see how you get there. Here's the H comma K. Remember, H comma K is the uh, vertex itself. And whether I know it's adding or subtracting is obviously if it's the focus, it has to be inside. So in order to be inside, I have to add to it. And I'm adding 1 over 4A to it. Okay. Remember, here's this A is right there. 1 over 4A, I would add to the y coordinate, and that's going to give me the focus. I subtract the 1 over 4A, and that gives me a point on the y coordinate of the directrix. The y's are all the same along here. Whatever that value is, that's the equation. Y equals that y value. Okay. So we're adding in focus and directrix now and understanding their definition as well and how you come up with them right there. Okay. So since, and the reason it's absolute value is because, you know, distance is always positive, so we make sure it's positive. Doesn't matter if I go up or down from the vertex. Let's make sure distance is positive, so the absolute value around it. So from the vertex to the focus or vertex to the directrix, it's the same length, 1 over 4A. Okay. From there. All right. Let's go ahead and look here. Write this in standard form, should say vertex form. Identify the vertex, axis of symmetry, and the direction opening of the parabola. So first thing I need to do is I need it to be a 1 right there, so I need to factor out the 2. I'm just talking about these two p's right now. So I have x squared minus 6x. I factor out the 2 there, kind of be x squared, 1x squared. Then I need to complete the square. You do this all the time with circles in geometry. Plus blank. And then I have this minus 25. So I'm adding something, I'm also subtracting that same amount because I'm leaving it on the same side. Well, where do I get this? We know this from geometry, 1/2 of b quantity squared. That's what I'm pounding your head if you were in my geometry class. Okay, so half of b is -3, and -3 squared is 9. That goes there. But you really did not just add 9, this 2 is out front. So you've really added this 2 times the 9 that has to get distributed there. So you really added 18 to the problem. So I need to subtract 18. Okay. So now I have 2 times x minus 3, 20 squared, and -25 minus 18 is -43. Exactly what we have right there. Now the vertex, remember, is h comma k. So that is 3 comma -43. That's the vertex axis symmetry. It's vertical, so it's y equals, so it's x equals the x coordinate here, 3. That's the axis of symmetry. You could just say symmetry, S-Y-M-M, symmetry. It's an equation, x equals 3. You can't just say 3, it has to be x equals 3, equation. And the direction of the opening of the parabola, since A is positive, 2 is positive, opens up. Okay. And there you go for that. And of course, is explained here as well. But now you just tell me how I would do it by hand. Okay, so that's what you're doing here. Same exact directions. The backside, now we add more onto it. Graph parabolas. Okay, put it in vertex form, not standard form. use the values of A and H to determine the vertex, the focus, the axis of symmetry, and the length of the lattice rectum. Okay. The vertex and the endpoints of the lattice rectum give 3 points on the parabola. Okay. Just lattice rectum. Let's say that was where the focus is. The lattice rectum is horizontally from there to there. Okay. That is the lattice rectum right there. All right. So that's why I talked about the endpoints of the lattice rectum. Give 3 points on the parabola. See, like that, there'd be a point on the parabola, there'd be a point on the parabola. In the vertex right there. So vertex and the endpoints of the lattice rectum are 3 points on the parabola, and then you can just sketch the rest of the parabola through there. Okay. If you need more points to plot an graph, substitute value points near the vertex. Okay. And so we'll talk about this. Okay. Now notice this example, it just says graph that. Now, I don't need all the focus in the lattice in the directrix in the lattice rectum to graph it, so they should ask for more than that. Let's see what they say in the directrix. Write an equation for each parabola described. Oh, okay. So you're going to have to be able to use that to go backwards to write the equation. So I don't know why they didn't give me an example like that. They just have the graph of this right here. Okay, so let's just practice graphing it using the information. Okay, so we know the vertex is 1, 2. So 1, 2 right there. Okay. We know the I just add 1 over 4a inside and subtract 1 over 4a to get down to the directrix. What is a? A is 1/3. So 1 over 4 times 1/3. So it's 4/3. Well, 4/3, 1 over 4/3 is the same as the reciprocal of 4/3, which is 3/4. So I'd go up 3/4 right there and go down 3/4. Okay. So that point for the focus is 1, I added 3/4 to 2. 2 plus 3/4 is 2 3/4. Then I subtract 3/4 from 2. Remember the directrix is a line. Y equals, what is 2 minus 3/4? 1 and 1/4. Okay, or you could have said 5/4. Same thing. So that's the equation of that line. 5/4. Y equals 5/4. So y equals 1 1/4. Okay. The length of the lattice rectum is 1 over a. Remember, it's absolute value of 1 over a. Well, a, remember, is 1/3. So 1 divided by 1/3 equals 3. So that means that from here, I go 1.5 out. From here, I go 1.5. Here I go 1.5. And that'd be a point right there. That's a total distance of 3. I'm going half each direction. 1.5 out to the left, 1.5 out to the right. And that gives me 2 points. And I already have this vertex. And so now I can do my sketch of my graph from there. Okay. So that's using the lattice rectum to help come up with the endpoints of the lattice rectum to get 2 more points on the parabola. Now, did you have to do that? No. Remember what I told you before. Once I've gone ahead and got to the vertex 1, 2, then I can take that out. And the general shape of the graph, as I showed you before, is 1/3 x squared. Okay. And so I might pick, and then when I use that 1/3 x squared, the vertex of 1, 2 is now the origin, the new origin I'm going out from. So let's say I say x is 3. and -3. The reason I'm picking that because I go 3 squared, that's 9. 9 will cancel with the 3 nicely 3 times. So that means if I go to the right 3, 1, 2, 3, I go up 3, 1, 2, 3, and there's that point. Let me put that right there. And I go left 3, 1, 2, 3, up 3, 1, 2, 3, and there's that point right there. So if it just asked me to graph it, that's what I would actually do, is do what I just did right here. Okay, but that's not what these questions down below are asking you to do. They're giving you different pieces and have you write the equation. That's different from what this is, this example. But if it just asks you to graph that, I just plot the vertex 1, 2, cross those out. Then you use y equals 1/3 x squared. Come up with 2 more numbers right here like this. They're going to cancel out nicely, so you get integers, and plot those other two, and then draw your parabola from there. Okay. Since they didn't do that, let's go ahead and look at one of these 3. Okay, notice they either give you the vertex and the focus, the vertex directrix, vertex directrix. Okay, so since remember the distance from the vertex to the focus is the exact same as the vertex to the directrix, same distance away. Okay, write an equation for each parabola. Okay, and graph it. So we'll do number 2 here, since there's 2 with vertex and directrix. Vertex 4, -5. 1, 2, 3, 4, 5. I mean 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, -5. The directrix is y equals -6. So notice that only went 1 down. Sometimes I go 1 up to get the focus. There's the focus. Okay. Now remember the distance from the vertex to the focus is 1/4a, and that distance is 1. Okay. We already know that you're going 1 up from the vertex to the focus, or vertex to direction is 1. So I said equal to 1. Okay. Cross multiply, you get 4a equals 1, and therefore a equals 1/4. Remember where a is. Our general vertex form is ax minus h squared plus k. So now I have the a, it's 1/4. So my equation then is y equals 1/4. And then what was my vertex again? I have it right there. X, I'm doing the opposite, -4, quantity squared, and the same, -5. And there's my equation of the parabola right there. Okay. What is the, okay, so now I want to graph it. Okay, so I've already gone ahead, going back to what I did in the last example up top. I've taken out those 2 now, so the general shape of the graph is y equals 1/4 x squared. Remember, this now is my new origin. When I do my XYT chart, of course, I want to pick 2 numbers going to cancel out nicely. So if I go x equals 2 and -2, that's going to give me 4, and 1/4 of 4 is 1. So I go 2, right 2, up 1, left 2, up 1. Right there. And so there's my general shape, and I can now connect it and draw my parabola from there. If I wanted another one, I can, next one to cancel out would be 4 and -4. 4 squared is 16, 4 is 4. Okay, so I can go right 4 and up 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. So that would be more accurate right up through there. Okay. 1, 2, 3, 4, and right there. Okay. And there would have been my more accurate parabola if I want to do that. Okay. You do not have to plot in the latus rectum. They're not asking you that. Okay. And that goes, oh, is that the second page or the first page? That is the second page, right? Yes. Okay, 19 minutes.